All right, here we go with the last page of these notes. Ugh, these transformations. Excuse my dirty hands because I have marker all over them. All right, here we go. So this time we got a table. So only a few things. So cubic polynomial, selected values, so that just means x to the third, right? So here's m of x. So m of x is a change to this function p of x up here. So describe the transformations. So let's do it here, negative. So that would be a reflection over, think of it, the x-axis. All right, 3. That is going to be our old stretch. So it's going to be stretching us taller, right? So it's going to be a vertical dilation by a factor of 3. Okay. All right, so this wording. All right, moving us left 4. So that is a horizontal translation by, or of, I guess, negative 4, because it's moving us left. Okay. All right, name an x value where m of x has a 0. So remember, a 0 is an x-intercept. So it's an x value where the y value is 0, yeah? So I want m of x, I want the answer, I want m of x to be 0. So I want this problem to equal 0, okay? So let's do that. Let's just put 0 equals negative 3 p of x plus 4. Okay, so I can divide the negative 3 out and still have 0 equals p of x plus 4. Okay, so let's ask ourselves, this is p up here, right? When is p equal to 0? So ignore this x plus 4. So just think about it. When is p equal to 0? It's equal to 0 here. It happens at 2. So this would have to be equal to 2 to make this true. So I make myself a little equation. I say to myself, well, x plus 4 would have to equal 2 for me to get an answer of 0. All right, so then solve that. X equals negative 2. All right, next one. The average rate of change of mx over the interval from 0 to 2. All right, so I need to find m of 0 and m of 2, so just like on my test from the first test we had, and so I can go ahead and do my average rate of change. So m of 0, so I'm going to be plugging a 0 in here, so it gives me negative 3 p of 4. So p of 4 is 3, so 3 times negative 3 is negative 9. Putting a 2 in here, I have negative 3 p of 6. So p of 6 is 7. So 7 times negative 3 is negative 21. All right, so my average rate of change is going to be, I need to subtract these and subtract those. So I think I will do negative 21 minus negative 9. And then I'll be doing 2 minus 0. So that's plus, let me see, that's negative 12 over 2. So negative 6 is my average rate of change. All right, the domain and range of m of x. All right, so let's see. So the old domain and range, let's do the domain and range of this guy, and then we'll make these changes to it. So my old domain, so for my p of x, let's do my domain and my range, and then we'll make the changes. Okay. All right, so good old p of x up here, the smallest x value that I see up there is negative 2, and the biggest is 6. So negative 2 to 6. So we'll just say negative 2 to 6. And I mean, technically, I guess I should like list out all these numbers, but they're gonna change in the same way, so let's just leave them like that. All right, and then my range, the lowest is negative 1 on the y's, and then 7. Okay, so let's do our thing. So first, let's see. They're reflected over the x-axis. So that means all my y values go ahead and they change. Sorry, I'm just thinking for a second. So my y values are reversed and then they're multiplied by 3. Okay, so my y values are reversed in the sense that they're opposite, right? So I'm going to flip the -1 and the 7. It's going to be -7 and +1, right? And then I have to multiply them by 3 because I'm stretching everything by 3. So I'm going to get -21 and +3. Right? I don't know why I did the y values first. I just did. All right, over here, my domain. The only thing that's changing the domain is this motion of left 4. Everything else was basically like a y value change. So I'm going to go left 4 more from these numbers. So I'm going to be like -4 and 2. Okay. All right, last one here. For which value does m of x equal 3? So remember, m of x is this equation here. So I'm just going to put a 3 right there. So 3 equals -3p of x plus 4. All right, so let's divide by -3, so I get -1, p of x plus 4. Okay, so to get rid of this, I need to say to myself, hey, p of what? What does x plus 4 have to be to produce a -1 for an answer? So it has to be 0. So you see, if I plug in 0 in the p function, I get -1. So this has to equal 0 for this to be true. So I make an equation, x plus 4 has to equal 0, so x equals -4. All right, last one here. So I'm given a domain and range, increasing here and decreasing there. So, well, I don't know, let's just try to make a little picture. All right, so my domain goes from -6 all the way to 9, and my range is from -8 to 10. It's increasing from -6 to 1. So I'm just going to draw something that's like going up, all right? Decreasing from 1 to 5. So we'll say 5 is here. I'm going down. And I'm increasing from 5 to 9, so going back up. Okay, so you don't have to do this. I'm just drawing a little picture to, like, you know, this picture will be different for every person, but like I just drew a little picture that did these things. Okay, so let's go ahead and look at our, oh gosh, this one is horrible. Okay, so I like to write this a little bit of a different way. I'm going to put this 4 on the end. So the -2 is in front, n of, let's leave this for a second, and I'll put the 4 on the back. So now I can see, oh, it's moving up 4. There's been a reflection. Now let's talk about this 5 minus x. That's also kind of weird looking. So let's write that as -x plus 5. And even further, I need to write it like this. I need to pull out the negative sign so that I can really see what's going on. If I pull out the negative sign, this turns into x, and if I divide 5 by -1, I get a -5. So you see how if you multiply that back together, you would have this, and if I turn it back around, I have this. But this expression lets me know everything that's going on, negative and then x minus 5. It lets me know that you have reversed me, you have reflected me over the y-axis, and you've also moved me right 5. Okay. All right, so you've moved me right 5, you've reflected me over the y-axis and the x-axis, you've stretched me by 2, you've made me taller by 2, and luckily you haven't done anything horizontally, and you've moved me up 4. Phew. All right, so let's find the domain and range. So let's write my old one. So my old one, n of x, my domain and my range are going to be -6 and 9, and -8 and 10. Okay, so I guess I should have had like an open circle right here. Whatever. Okay, who cares? All right, so now my new one. So we have to do this in pieces. Let's see. My domain. What changes my x values? So what changes my x values? You don't change my x values if you flip me up or down. You don't change my x values if you multiply my y values by 2. It's this part. This changes your x values. So flipping you over the y-axis, reflecting you over the y-axis, reverses your x values. So why don't we do that? So this would reverse to 9, -9, and 6. Okay? And then you've moved me to the right 5. So move me to the right 5, that means I'm increasing, going to the right, so I would be at negative 4 and 11, both brackets. Okay. Phew. All right. Range. So what changes my range is you moving me up 4, but also multiplying me by 2 and flipping me over. Okay. So my range was negative 8 and 10. You flip me over, so then I become negative 10 and 8. And then you multiply me by 2, so then I become negative 20 and 16. And then you move me up 4. So then I become, finally, 20 and up 4, so that'd be negative 16. All right, last one. On what intervals is my new problem increasing and decreasing? All right, so now, oh my God, this is hard. All right, let's see. So you know what? Let's just do decreasing for now, or let's just think about it. All right, so if you have this shape and you flip it over the x-axis, then basically everything's twisted upside down. So like, let's do this one. This line would become looking like that, but then you flip it over the y-axis, so then it would look like this. So everything that is increasing is going to still be increasing, and everything that's decreasing is still going to be decreasing, because you're turning the graph this way, which changes it, but then you're turning the graph the other way, which also changes it back. Okay. All right, so we're just going to have to think about where these numbers move to. So let's take our old increasing, so negative 6 and 1, and 5 and 9. Now, these are only x values. So this is my increasing and my decreasing. So x values are only going to experience change from this part inside here. Stretching them, flipping, nobody cares. These are all y value actions, y value actions. So it's this part right here. So I have to flip it. So I have to reverse the numbers over the y-axis. So this is going to become negative 1 and positive 6. And then I have to move them to the right 5. So that's going to be 4 and 11. Right. And then this guy, I have to flip it, so it's going to become negative 9 and negative 5. Then I have to move everything to the right 5, so negative 4 and 0. So these two are increasing. Now my decreasing, again, x values, so flip it, negative 5, negative 1, so flip it over the y-axis, then increase it by 5, so 0 and 4. And this is my decreasing. Okay, now I know I have taken 13 minutes, but you guys in period 3, you should watch me. I'm gonna do one more problem, and I want you to just watch it. Actually, both of you, let me look at the homework here real quick. So this problem on the homework right here is a little bit weird, so let me just tell you about that. Then first period you can go, and third period maybe you stay for a couple minutes and watch this one example I have to do. All right, so on your homework right there, this is inverse, right? So when somebody tells you an inverse, they are really telling you this is, h negative 1 of x. But remember, inverses are switched. So the answer to this is really the y value, right? So because x and y are switched. So when somebody tells you this information, what they're saying to you is when you, the inverse with 4 plugged in has, so this is an answer. How am I trying to say this? So, let me tell you this. Let me say that if you have the point 3, 7, if you're doing the inverse, that would be 7, 3, right? So this is telling you that f of 3 equals 7. So then you would know that f negative 1 of 7 equals 3. Like that's how they work. all right? Because what's the x and the y switches. This is the x and the y here. They switch places. So by telling you this information, what you're really telling someone is that this is the y value of the original problem. So this really means right here that 4 is equal to h of x, okay? Because this input, this x value, is really the old y value of normal h. And once you know this, you can put it back in the problem. So 4 equals 5 minus f of 2x, and you can go and solve it like you did all the rest, okay? So that's that. I just want to tell you that. Now, last one here. Let me get my paper here. So on your homework, you're going to have some problems like kind of similar to this, period 3, and we didn't get to do this in class. So let me just tell you about it real quick. So you have a graph, and somebody is telling you to do this to it. So let's do it real quick. I'm going to transform how this looks. I'm going to keep my negative f of 2x out here, and then put a plus 1 behind it. That's a better way to have it written. All right, so I have to change this graph by doing this. All right, so here we go. So I have to reflect it over the x-axis, and then I have to do a horizontal dilation by a factor of 1/2. So that means this graph is going to get closer together. Okay, and then I'm going to move it up 1. All right, so let's take this point. So I'm going to reflect it over the x-axis. So it's at -4, so I'm going to make it into +4. There it is. I'm going to horizontally compress it by a factor of 1/2. So I'm going to move halfway in, and then I'm going to move up 1. So there's that point. Okay, let's do it again here. I am going to reflect it. I'm going to horizontally compress it by 1/2 here, move up 1. So those are connected. Right? Now we're here. I'm going to reflect it, horizontally compress it by 1/2. Oh, wait, I just did that one. This one, sorry. I'm going to reflect it, which does nothing. I'm going to compress it by 1/2. I'm at 4, so I'll go to 2. Then I'm going to move it up 1. And then this guy. All right, I'm going to flip it, reflect it, horizontally compress it. 1, 2, 3, 4, 5, 6. So I'll be at 3. And then I'm going to move up 1. All right, so you're doing these actions to this picture, which gets you a new picture. Okay, so there's a couple of those on your homework. All right, that's it. I'll see you in class. Make sure you do 1 through 8 on your homework. Bye-bye.